Hi there and welcome back to the channel. I'm the GCSE science teacher, and in today's lesson we'll be learning about ionic compounds. This leads on from a previous lesson I did about ionic bonding. So if you haven't seen that, I'll link it in the cards above for you. And this is part of topic 2 called bonding in GCSE chemistry. If you do find this video helpful, feel free to like and subscribe, join our community. Comment below, what are you currently studying at the moment? Are you in year 10, year 11, doing your GCSEs, or are you looking to the future and you're not quite at that stage yet, but you're revising anyway? Let me know below. It'd be great to hear from you. If you do want more support and help with GCSE biology, chemistry, or even physics, you can check out my channel, but also Instagram and TikTok, which has lots of resources there at the GCSE science teacher. So the question of the day is, what is this? And it's a picture of table salt. Table salt is made up of sodium chloride, which is a specific type of ionic compound. Remember, sodium is a metal. It will donate electrons and form a positively charged ion or a cation, whereas chlorine atoms will actually gain electrons to become stable, and they will form a chloride ion or an anion, which is negatively charged. And we're going to talk about that a little bit more today. So this is a dot and cross diagram, which you may have seen before. Remember that the dots and crosses represent those electrons. And at GCSE, you need to be aware of how ionic bonding forms between group 1 and group 7 elements, but also group 2 and group 6. The reason that these atoms will actually do this or bond in this way is to form stable compounds. So it's all to do with the chemistry, particularly of those. And if you want to learn more about this, I have that video. I'll link it in for you so you can go and explore that. But specifically, just to finish this topic off, is what are ionic compounds specifically? And in the previous video, I know that I mentioned ionic bonding, but an ionic compound is what forms afterwards. And we do see it in that dot and cross diagram as just two ions next to each other. But in reality, they're actually 3D structures. And that's how we see the salt, maybe like as we do the table salt. And it's because of these lattices, all these giant ionic lattices that form. And essentially, it's these ions that are interwoven together. So we have the non-metal ion and the metal ion alternating in positions like you see below, forming these 3D structures. And it's because of those 3D structures we actually have those substances that we do. They form those 3D structures, and the reason they form this way is because of the strong electrostatic forces of attraction between the ions. So the positive will attract to the negative charges. You need to be aware that these ionic compounds are 3D essentially. We know that we can draw and represent ionic compounds in a multitude of ways. So the dot and cross diagrams, we can draw them in 2D diagrams as well, but also 3D. There are limitations which they want you to know at GCSE. So the limitation of drawing out ionic compounds in a dot and cross diagram is that they don't show the ion arrangement in space. The 2D diagrams as well, they don't show where the ions are located, specifically if it's a large giant ionic lattice. It doesn't show the other layers of those ions. 3D diagrams are a bit better because they show the arrangement of those ions, but however, they are not to scale, and they also don't show the forces of attraction between the ions and also the movement of electrons, which is not ideal. So there are ways we can draw and represent giant ionic structures, but there are also limitations, which is always the case in science, really. So it's good to be aware of the limitations of these diagrams as well. To be honest, that's not a question I've seen very often come up in the exam, but it's something worth noting as it is on the exam specification. Empirical formula, though, however, is found on the specification, and an empirical formula is the simplest ratio of ions within a structure. So you saw that giant ionic lattice, and you'll have lots of sodiums, lots of chloride ions, or other ions, non-metals and metals. And you need to be aware that these structures are huge. They're giant ionic lattices, but you need to be aware of the empirical formula if you were to write down the simplest ratio. So, for example, sodium chloride, we know, looking at that diagram, there are lots of sodiums, lots of chloride ions. But if we were to simplify it and write it as one simple formula, we'd write NaCl. So how do we do this? If we're given a diagram in the exam, you want to count the number of each atom and calculate the lowest common ratio. That would be the way to do it. Often you put the metal first and the non-metal afterwards. So in the case of sodium chloride, you have sodium first, chloride afterwards. Also be aware of whether the charges match. So sodium is a positively charged ion. Chloride is a negatively charged ion. They cancel each other out, which is why you have one of each. It's the same with magnesium oxide. There's 2 plus for magnesium, 2 minus for oxygen, so you need one of each. However, in the case of other more complicated ionic compounds like aluminium oxide, you have aluminium, which is a 3 plus ion, and oxygen, which is a 2 minus ion. And this is where some students find this quite tricky. So for example, in this case, you would actually need 2 aluminiums and 3 oxygens. Now, how did we get there? Pause me and think about it. How did you get to this point? So hopefully you've unpaused me now and you've got an idea. Let's go through it together. Well, if you look at the ratio, you can see that we've got a 3 plus and a 2 minus. And if we want to cancel them out so they're the same overall, that we have a total cancellation of charges and it's even, we would have 3 plus and we times that by 2, we get 6 plus. If we have a 2 minus and we times that by 3, we get a 6 minus. So they cancel each other out. And that's essentially what we're trying to do. I hope that was helpful. It was a quick video, I know. Feel free to like, comment, subscribe. Let me know what your thoughts are on this video. If you did like it, like I say, it'd be great to hear from you. Feel free to comment and tell me what you're currently studying. Like I said at the beginning of this video, it'd be great to hear as well. I've been the GCSE science teacher and you have been curious. Thank you so much for your time and I'll catch you in the next one. Bye.